Hey guys, we're going to start out with a nice, easy lesson on relations and functions. Glad you could be with us tonight. Anyway, guys, we're going to start out chapter 2. Okay, we're these are the first round of videos. Hope you guys like them. We're going to go through, and again, if you guys have any questions, please message me on Emoto, and we'll get it going. All right, so anyway, relations and functions 2.1. Let's go. Okay, first thing, again, is that you guys are going to know, again, I've been doing better with the vocabulary. Alright, so we're going to go through all that. So again, you talk about the independent and dependent variables. You guys have probably heard these words before. Okay, at least I hope so. Okay, again, independent variables, it means input. Okay, something that you're putting in to the, think of it like a machine. You're putting in something and spitting something out. Okay, that's the input is always going to be your x values. Okay, and then dependent is what it spits out. Okay, it is the output or the y values. All right, domain and range are going to follow the same kind of pattern. You guys might have learned that when you're talking about algebra 1. Again, domain is always x, range is y. Don't worry about one-to-one functions. We are not going to worry about those right now. The vertical line test is just a test, a function test, I suppose. It will tell you if it's a function or not. And then function notation is going to look, again, basically all we're going to do is we're replacing y with f of x. All right, and that's pretty much it. All right, let's go ahead and get into it. So now again, a relation is just going to be any set of ordered pairs. I can give you just like, for example, 2, 3, with all these little fancy squiggly lines around them. Okay, 2, 3, 3, 4, and 0, -1. Okay, and this would be a relation. All right, now again, a relation is it's basically just any group, any way to group ordered pairs. That's pretty much it. Okay, now again, the input, like I said here, is called the domain, and the output is called the range. Okay, so again, remember it's always going to be x and y for the range. And then a relation is a function if there is exactly one output for each input. So what this means, okay, is that the x values can't repeat. My E's are terrible. Please don't judge me. I'm so sorry. Okay, x values can't repeat. All right, so again, in this instance, you know that an ordered pair is always x, y. All right, so again, you see that I've got 2, 3, and 0. So my x's don't repeat, so this is a function. All right, and we're going to go through a lot more examples like that. First one, this is called a mapping. Okay, mapping. Just a fancy way to display information. Okay, the side on the left is going to be x, the side on the right is going to be y. And again, all your things. So for example, this is saying like this right here, 2 pointing at 9. This would be. That would be the ordered pair 2, 9. All right. Again, that's basically it. So you see, we've got 2 going to 9, 3 going to 1. I'll go ahead and write them out. 3, 1, -4, -8, and then 6, 4. So when they ask you, is this a function? You're going to say, okay, do any of the x values repeat? Now, if it, and you see here after we write them all out, that none of our x's repeat, so we're good. Okay, so this is a function. Okay, now again, if you had seen something like this, if you had seen an additional arrow from 3, let's say, going to -8, so I would have had 3, -8, then it would have been no. Okay, because the 3's would repeat. All right, not too bad. Again, we're going to go ahead and I want to get you guys used to like these kind of terms, again, stating the domain and range. And then it's going to ask, is the relation a function? So again, you're going to start with, again, remember that it's always x and y, and the domain is x, range is y. So domain for this one, I'm going to do it in order, okay, is just going to be these fancy squiggly lines, -3, 2, and 3. Oops, that was not a fancy squiggly line. Let's fix that. There you go. All right, and then the range, again, in order. Don't repeat anything, too, if you need to. Okay, again, this is just going to be -2, 1, and then 3. Okay, now again, you see that my domain doesn't repeat. There are no repeating x's, so this is a function. I'm sure you're excited about it. That's why I keep putting on the exclamation marks. You're welcome. Okay, next one. Okay, you'll see for number 2, again, we'll do the domain. Is going to be, let's see, we got, so we'll do it in order. So -3, 4, 5, and 8. And then the range will be 5, 6, and 12. I'm running out of room there. Sorry, guys. All right, now again, you see that the only thing here is that the -3 is going to 2 different y's. Okay, so that would mean that this is not a function. Okay, now again, anytime an x repeats, not a function. All right, so again, here I'm gonna clear this because I'm kind of running out of room on my screen. So clear that. We're gonna do number 3. So again, you do the same thing. So domain. I'm gonna go a little bit faster because I think you guys are getting the idea. Is -2, 0, and 5, just the x's, and then the range is 1, 3, and 4. Okay, and you see that my x's do not repeat, so this is a function. And last one, domain will be -2, 4, and 5. You guys got to practice your fancy squiggly lines. And then the range will be 2, 7, and 7. Okay, now again, you look at your x's. No repeats, so this is a function. Okay, now what I want you to do here, I gotta make sure you get everything down, but I want you to make a note here that it's like, just write something that y values can repeat. Can repeat. Alright, so no problem with y values, but the problem is with x values repeating. Alright, let's keep going. These are all just more examples. Okay, if you guys want to pause and try these yourselves, you can. I would, again, you see here the x's, no repeats here. For these guys, though, it's a little bit different. And again, if you, like, for example, I would just, for these guys, I would just use, just make a t-chart and use -2, -1, 0, 1, and 2. So this is for your x, these are for your y, and plug them in and see what you get. Like in this one, for example, you plug in -2, so it'd be -2 squared is 4, 4 times 2 is 8, 8 minus 4 is 4. -1, -1 squared is 1, 1 times 2 is 2, 2 minus 4 is -2. Plug in 0, 0 squared is 0, 2 times 0 is 0, so -4. Same thing with 1, 1 squared is 1, 1 times 2 is 2, 2 minus 4 is -2. Okay, and then the 2's again, you'll do 2 squared is 4, 4 times 2 is 8, 8 minus 4 is 4. So I'm not getting any repeating values. Alright, so this would be an example of a function. Alright, let's go ahead and move on. Next thing is function notation, and the most important thing, like I told you, is that y is now going to be written as f of x. Okay, this is how you say that. It would say, right? Say it as f of x. Okay, and again, f of x is just the name. It's just, it can be anything. It can be g of x. It can be, I don't know, z of x, anything like that. Okay, and it doesn't matter. Okay, so again, x, we've already, again, I've hit this a couple different times now. Okay, x is always the input or the independent variable. Y or f of x is the output or the dependent variable. Okay, make sure you guys are making those distinctions because it is important. All right. So now the main purpose of function notation is what you're going to see. It's going to ask you, for example, my function is g of x equals 3x plus 9. Imagine this. Oh, lights went out. We're good. Okay, so again, this is going to be your machine. Okay, and whatever it says in here, this is what you're plugging into your machine in order to see what you get out. Okay, so you're going to take the 2, plug it in for x. That's all it's telling you. So again, pay close attention, guys. I'm going to show you what this looks like. So g of 2 equals 3 times 2 plus 9. Again, all I've done is just take the 2 and put it in for x. Alright, now we can go ahead and solve it. So 3 times 2 is 6. So 6 plus 9 is 15. So g of 2 equals 15. Now again, what I've found is an ordered pair on my function. So I can rewrite this as 2 comma 15. Remember, this is x and this guy's y. Alright, next one. Let's do the same thing. Again, this is, again, we're taking negative 3, we're plugging it in for x. So this will be g of negative 3. And I encourage you guys to pause the video, see if you guys can try it and do it on your own. So 3 times negative 3 plus 9. 3 times negative 3 is negative 9 plus 9. So g of negative 3 equals 0. And again, the ordered pair is negative 3 comma 0. Let's keep going. I'm going to skip this one. Okay, if you want to try this one, your answer should be negative 51. But I want to show you this one now. Again, you see I have a y value in here. So all you're doing is you're taking this exact thing, y minus 3, and you're plugging it in for x, and then you're simplifying. That's the only thing you can do, because again, you have a y here. So let me show you what that looks like. Again, so m of x is my new function. So it'll be m of y minus 3 equals, again, take y minus 3, plug it in for x. So negative 5 times y minus 3 plus 4. Here we'll distribute, and it'll be negative 5y. Negative times a negative is a positive 15 plus 4. And combine our like terms, so it'll be negative 5y plus 19 is equal to m of y minus 3. Okay, there we go. Again, I'm gonna have a few back here that you guys can try. Again, I'm gonna leave this up. I want you guys to try them on your own. Again, we'll go over them. For this one, you should get 10. And I want you to try this one. I don't want you to tell you the answer here, because again, you're gonna. Well, I guess I could. Again, this one will be 48t squared minus 2, I believe. 14 squared. That should be, yeah, this should be what you get. Alright, let's keep going. I want to show you, there's got one more thing I want to show you, or two more things rather. This is going to be just a really quick review of the coordinate plane. Again, you guys know the axes. Again, this is the x-axis. Okay, this is the y-axis. Okay, we've got our quadrants. Okay, they start in the top right, so you got to go 1, 2, 3, and then 4. And you guys know that this one is the origin right here at 0, 0. Again, you should all know that. Again, just as a refresher. Hopefully, you remember those. Okay, next thing we've got, we're going to graph each of these ordered pairs and then tell which quadrant they lie in. Okay, so again, these first two are easy. Again, you got 3. Again, it's always x, y. So you're going to go 3 on the x and then 2 up on the y. So right here. Okay, and you guys can see, obviously, that's in quadrant 1. Remember, it goes counterclockwise. 1, 2, 3, 4. Next one is negative 4, comma 0. So negative 4 on the x and then 0 on the y. Now this one's actually not in a quadrant, so we can just say that it's on the x-axis. Alright, now these guys actually I cannot graph. They're not on my graph, and that's okay, but I can tell you which quadrant they're in. So if I went negative 6.5 over and then negative 1.75 down, I'd be in the third quadrant. And the last one, if I went 10 over on the x and then negative 3 down on the y, I'd be in the fourth quadrant. And that's all there is to it. Last thing, guys, I want to show you is the vertical line test. Go ahead and write this down. All you're looking at for like a visual graph. If you use a vertical line test, your function can only hit it at one point. So let me show you what that looks like. You see, I've got 4 different functions here. So you use a vertical line test. You see that it only hits it at one point each time. So that one is yes. Same thing here. Yes again. This one has the one going up and down, so that one's no. And this one, if you use a vertical line test, it only hits once. All right.